Hey everyone, happy Monday. I got Josh Weisel here, my weather intern. We've been having fun today looking at the different models, and I just wanted to provide a quick update. We don't know all the exact details, but I do know this system coming in on Wednesday into Thursday is stout. It's got me concerned. It's got me a little bit troubled, and I think it's going to bring trouble. What do you think,
It
Josh?
it looks kind of crazy already, and given the fact that the models have been so flip-floppy and not really the best, and we've seen so many surprises with systems like this, I think it's better to be almost overly prepared than it is to downplay these systems as they move in,
Yeah.
especially with the strength of this thing.
So Allie says right here, that anything can fall apart, which is 100% true. It can, but my problem is that golly, the energy is so intense.
Yes.
Number one, my brother's getting blasted on the West Coast. I was talking to him today. In fact, I said, "Watch, he's gonna call and he's gonna say the weather's crazy, didn't it?" And
Mm-hmm.
then he called. What was his first words?
What's the weather doing?
Yeah. And what did he say about his weather now?
He was saying that it was not pleasant.
Not pleasant. No, no. All right. So here's what we've got. Let's dive into it. Not going to spend a whole lot of time on this, but we'll see if we get a lot of questions. I'll keep going. You know me. We'll talk about weather for days. Here's the severe weather risk for Wednesday. So this is Wednesday's severe weather risk. And by the way, just to let you know, this does include, even though it doesn't really include the River Valley, I think this is going to shift tomorrow. I think the risk is going to be shifting north. So here's the deal with this system is that number one, you remember the thunderstorms that developed on Saturday? Well, guess what? There was a little piece of energy that came off the area near Baja, and then that eventually formed additional storms that were very highly electrified,
Mhm.
more intense than what anything, at least what I looked at from Thursday. I don't know about Friday. Zach said it was started to put it in there Friday, but so the main threats for this, you don't even get the threats because it's a day three outlook. But I think hail and maybe a tornado potential in Dallas Fort Worth area. Looking at some of the models, so that's kind of what we're looking at. Amanda said you just washed your car today. I believe it because it looked like a mud storm came through. But I know Josh is like, not again. Yeah, Josh, that was a busy one. I appreciate your efforts though. All right, so here's what we've got for the severe weather risk on Thursday. All hazards possible. The timing's going to be mainly Thursday afternoon. Jacob's asking, could the temperatures be underdone for Thursday? Absolutely. In fact, I went on the lower end of the temperatures for Northwest Arkansas and the River Valley. But the problem is we're really going to have a lot of energy. So I want to show you what we're up against here. This is a lot of energy. So first of all, what you're looking at is a big system that's out on the West Coast. The West Coast system is intense. Uh, there's a lot of precipitation that's falling in the form of snow, really heavy snow, crippling snowfall, and you're going to see this start to dive in. Now, there's another piece of energy on the back side. Now, look at this thing. This is called a positively tilted trough. So, what do we mean by this? If you're walking from left to right, and I divide the trough axis in half, where you kind of want it even on both sides, if that line runs from bottom left to upper right, imagine you're walking from left to right. Well, it's harder and you have to exert more energy if you're walking from left to right. Let me draw a line on here. So what we're going to do is we're going to draw a line. We're just going to divide that trough axis, just like this. This is what I mean. So we're dividing the trough axis. So if I'm a little man that's walking, all of a sudden, or man or woman, and then I hit this line, I'm going to be walking uphill. Walking uphill exerts more energy. Therefore, it's tougher for this storm system to cool the temperatures aloft, to give you those westerlies aloft, which will allow for favorable storm motions. Now, watch what happens over time, though. As this system swings in, now look at the trough axis. In fact, you can see it the way it's split. So we're going to go right here. I draw another line, and guess what we've got? We've got positive going to almost sort of to neutral. Now watch what happens after that trough axis starts to move east of our area. As it's swinging through, look at this. Oh my goodness. So now we draw the trough axis, we split it in half, and now look, you've got a line that's going upper left to bottom right. And if you're a man that's walking or a person that's walking and you hit this hill, guess what? If you've ever run downhill, it doesn't take a lot of energy to keep going. So that's a look at this negative tilted trough. That's number one that tells you watch the heck out as this system comes ripping in. Once again, we're going to animate that and loop that. Now notice the precipitation stops. The reason the precipitation stops, that only goes out 5 days, and everything else is loaded up to 7 days. So you won't be able to see the precipitation move, but look at ahead of it, all that thunderstorm activity that's erupting right there, 6 o'clock in the evening. We'll take a closer detailed look at this, but there's the energy that's zipping in, becoming negative tilt. Here's a look at the jet stream, and there you see the positive tilt, and then you're going to see it transition to negative, and that's just trouble. So essentially what's happening is this system is flinging the energy in. It's kind of like a softball pitch. You take your arm, and then when you release it at the bottom, that flings the softball out, and then it just goes absolutely crazy. So let's take a look at some of the computer model forecasts. So this is what we've got for Wednesday. I've increased and included the rain chances. And you're going to see Wednesday night into Thursday morning, some thunderstorm activity. Now, this is not very high resolution right here. It's a 9 kilometer. Actually, this is the 25 kilometer GFS. I guess that's all it offers. But you can see right there, not much in terms of details. So we don't have all the details yet. But as the system comes through, there's going to be very, first of all, intense wind. What do you got? What you laughing at?
Just laughing at that.
I know.
Winter freeze.
Stupid. And then there's precipitation that forms, and it's going to be kind of like a wet snow. So this is Wednesday into Thursday for those that are asking and those that are looking. Let's go to the European model, and we'll take a look at that system because it still is impressive. So there we go. Load this up. I just want to make sure I have all those pause points. So here's the European model. Wednesday, thunderstorms, and I'll show you the more detailed look. Look at all that thunderstorm activity coming in Thursday night. That's when that energy flings in. That's when the system rolls through. And then you can see Friday morning, I think there is going to be some wraparound. I know, it's stupid.
It's like a roller coaster.
Oh,
Arkansas.
my
We go
goodness,
from
I hate
severe
it.
to winter in just a matter of hours.
So tomorrow is going to be gorgeous, beautiful, no problems there. Let me show you the zoomed in view here. This, I think, goes out to Thursday. So there's the thunderstorm activity in the river valley. I'll bring the camera, take it off there so you can see. So there's the thunderstorm activity in the river valley. That's going to be popping up. And then you're going to see, as that clears out, Wednesday night into Thursday morning, here comes the next round of energy. And watch this. This is probably going to just explode with thunderstorms. Look at that. So that's Thursday morning, which makes sense. There's going to be some energy on the leading edge. And, oh, man, it's kind of going out. It's wigging out. Hold on. Shh. Let's see if it goes out a little farther. Stand by it. Go out just a little bit farther. Let's go to like 67 hours. Let's see if we can do that. Yeah, there you go. Wow. And the problem is even though that's a cluster of storms, the instability in the wind shear is tremendous. Now, I will say this, Northwest Arkansas is a little more uncertain in terms of the severe weather potential, in terms of tornado potential. But I will say that River Valley is really, really under the gun. You got to watch this system close. So that could bring some serious trouble right there. Let's go back to the NAM 3 kilometer. This is the very latest. I haven't even looked at this. So let's see what it shows. There's Wednesday's system. And then there's Thursday morning, which makes sense. And I guess it doesn't go out far enough. So NAM 3 kilometer doesn't go I know, during rush hour especially. So here's what we're gonna do real fast. We're gonna load up some different models with our computer, and we'll show you one that we're really watching in particular. So this is the Josh model, and it's really actually pretty good. Let me tell you, it's a really good forecast model. It's the Texas Tech. Make sure it's brought up. It is. So this is the Texas Tech WRF, basically the Western Regional Forecast Model. And then you're going to see right here thunderstorms popping up in Dallas during the afternoon on Wednesday. So this is Wednesday afternoon, March 1st. Look at those storms, man. Yeah. And then you can see them exploding for south central Arkansas and into central Arkansas. Maybe not as much activity, but I still think some thunderstorms will be possible in our area. And then that model doesn't go out to Thursday. Can't wait to see what it shows on Thursday. But other models do go out to Thursday, including the NAM. And this is not the 3 kilometer, but the 12 kilometer. And you're going to see right about there a pretty nasty line of storms. Now, those could be basically supercells. If we look at the supercell composite, look at this. Golly, that is not good. And then you look at the significant tornado parameter. Holy smokes. So that's
crazy.
That's up on the upper echelon. So it's loading up my goodness. Yeah. That's pretty impressive.
I haven't actually seen so far this year, at least personally, that bright of colors with that model in particular with any of these setups.
Yeah. So here's some of the stuff with the sounding. Supercell composite of 23. The significant tornado parameter of 7.4. And the fixed layer is 5.7. That's still impressive. And then you see up here, look at the effective layer, significant tornado parameter with the SIN, which by the way isn't very much. There's a little bit, but there's not much. Critical angles a little bit off of 90, but still very impressive shear profile. And if we look at the sounding, that's not very far away from the River Valley, from Fort Smith, Van Buren. Does it make it into Northwest Arkansas? Doesn't look like it as a boundary comes in. There you go. PDS tornado right there. Man. It's interesting how there's no matches on that. You know what? I wonder if we could look at SIPs. I'm going to bring up the SIPs computer model archive. But let's go back to this, and we'll look at some other stuff here. 0 to 1 kilometer storm relative list. We already know that's off the charts with this system coming in. Notice how there's a lack of it in Northwest Arkansas. Here's another model right here. We'll look at this. It's another sounding. So this is impressive. This is the European showing tornado potential Thursday afternoon. Go back here. So there's Thursday afternoon. You can see it popping up. Now watch what happens Thursday night. The energy kind of flings. This is when that energy is really flinging in. Now you showed me something with the NAM. If we look at this with the tornado parameter, and you're going to see this really crank up on Thursday. Watch this. Right here. There's Thursday night, and then look at that. There's Friday early morning. So essentially, basically midnight into Friday morning, but
pretty alarming.
Yeah, so from 6 p.m. to midnight, it's going to be your time, and then look at that, just race off to the northeast. So the severe weather potential for damaging winds, I still think we see that as well. Watch this race northward too. Right there, that still includes parts of the Northwest Arkansas area. So all things that we have to watch, we have to look at. Here's the newest HRRR, the extended one. Look at the thunderstorms popping up for Wednesday. And they really crank up as that next piece of energy moves in. And then that system shifts off to the east. Now, if we look at these are some of the other models. This is the newest GFS right here. And so let's look at some of the parameters with the newest GFS. Hey, collapse. Let's look at the EHI, Energy Helicity Index. And there you go. There it is, right there. I hate how it shows it and then it doesn't. You can never get it on there. So 3.3 LaFleur County. This is what it looks like. That's pretty impressive. Maybe a little bit of a weird profile there, but nevertheless, very steep lapse rates. That's what I'm concerned about. That's why those negative tilted troughs are so important. Let's go to the photographs. I bet you they are just off the charts. Let's see here. Yeah, that's extremely favorable. For that critical angle. It just all depends on the instability. Of course, the GFS usually is underdone on the instability. ARW doesn't go out far enough. So we're going to get more data as it becomes available. But here's what I want to do, Josh. It'll take a little bit of time to do. But what we have to do is load up the SIPs. So the SIPs analog will tell you the potential for severe weather according to other things.
I will say that HRRR and the TTU are almost in full agreement with those Southwest Arkansas storms on Wednesday.
Yeah, they are. Okay. So let's see here. So there's the probability. So this is all. Let's see here. Maximum wind gusts. I don't want any of that stuff. Percentage of severe. So we're still a ways out. We're not quite in the time that we need to be. So we got to go back. Let's load up a different time here. 48 hours. You can see the trough coming in. We're still not good. We got to go to extended analogs. And sometimes these go out too far. So let's see what we got here. Yeah, that's going out too far. But look at the severe weather potential here. So we'll scroll over here and we'll look at something else here. Yeah, see, it goes out too far. So we're kind of not in the sweet spot there, 6 to 8. So we got to go back here and we'll load this up. So if we look at hazard guidance and we'll look at severe reports, let's look at the tornado potential. So this, by the way, is through March 1st. So it's not really good yet. CWASP analysis. It just doesn't. You got to have that sweet spot for time, and we're not there. So we're too far out. It's 24-hour and 48, so we can't really get it. Yeah. There's another system coming in next week, but we'll have to do that later. So current run. Yeah, this won't go far enough because you can see the energy coming in from the west, but it's just not the right time. Okay, so that was a fail. All right, well, what we'll do, you didn't want to see it anyways. Okay, so let's go back to some of the comments here. Let's see. These temperatures are so nice. Yeah, I know. I'm not looking forward to any chances of snow either. Charles says that tie last night, Lightning Dan. Yeah, we had the lightning tie on, and I changed it when we had the tornado warning. Creeks were a bit high today to fish. I can believe that. Oh, the system's not looking good. I could deal with the rain, but not this wind shear crap.
Agreed.
Let's see. Thanks, y'all, for being so conscious. Yeah, we just want to let you know ahead of time. So, hey, Jason Boggs. You know who that is? My storm chasing partner back in the day, man. And a good friend of mine from Amarillo. So how about this? Does this mean high chance for several tornadoes like EF4s, EF5s, or high-end tornadoes? Well, all the ingredients have to come together, obviously, but and tornadoes are extremely rare. But regardless, it's something that we definitely have to watch. for sure. Yeah, you know why the 0Z wasn't updated? Because it was out too far. Here you
Is
go.
that it?
Yeah, here you go.
Wow.
There's probability of 5%, and then yeah, that's why we had to go to the previous run. So let me do this. Let me load this up for you. Hold on, stand by.
Looks like spring is waking up.
Spring is definitely waking up. So here is the SIPS analogs. All right, and then we're going to click on this. Make sure that you can see that. Okay, this is the probability of severe weather potential, and you can see it's way up there. And if we go to click off of that, shrink that down, scroll over, you can see all the different probabilities. Here's 5 or more severe weather events, and that's really over our area too, so you can easily see that. And that's 84 hours out. That's the system that's coming in right there. That's our time too. So if we go back to the SIPS analogs and we click on this, let's see if we can get 12Z. Here's what we're going to do. We're going to click on this. 48 hours. Z. Let's go back to a different run. So there's a hazard guidance, any severe. So 5 or more. You can still see it showing up too. Percentage is there, 13%. I mean, that's 4 days out. That's pretty impressive that it's showing that.
Mm-hmm.
How about a SIG Tor? Doesn't show SIG Tor. But this isn't really the time. Look at Dallas.
Dallas looks.
It's got that. This is for Wednesday.
Wednesday looks like a bigger day than.
Yeah, I think
it's
so
been
too.
setting up.
Top analog is 1994, February 24th, 2011. Look at some of the other dates. Look at that, right before. Holy cow. See this date? 02/03/2008.
Mm-hmm.
What was that? That was 2 days before Super Tuesday, the tornado outbreak.
Mm-hmm.
That's 2 days before the system moves in, or 1 or 2 days. Yeah.
That's crazy.
Wow. That is crazy. All right. Well, something to watch for sure.
That's the problem. That's the problem with these systems is you're gonna have to watch them very carefully. But we're getting to the point where forecasts are going to be kind of like a broken record, where we're going to get pretty much a system every week. Haven't been quite this strong. We've seen some strong ones, but it's just that time in spring where we're just going to have to keep watching these every week or so.
Yeah. It is Severe Weather Awareness Week, Jacob, and this topic tonight is flooding. So turn around, don't drown. That's what you want to do in flooding. But there's many different things with flooding and stuff like that. So the GFDL is nuts and is very organized severe weather. I'm telling you, I don't like this system at all. Thursday, we're gonna be going nuts. So yeah, I think the enhanced risk will shift north? Yes, I do. Looking at the latest data, I don't think it makes it into Northwest Arkansas as of now. And the reason for that is we got this front that comes through and it kind of stalls out right over Northwest Arkansas. So, yeah, I did not see a video from Norman. I've seen video of the damage, and I was watching the streams live. And by the way, we've got the archive. We were looking at it. You want to load it up real quick? Sure. There we go. I think this is it right here, isn't it? Yep.
Which, by the way, for anyone wondering, they updated it this evening. It was officially ranked a higher end EF2 between, I think it was 130 and 135 mile per hour winds.
Yeah.
And then the Shawnee tornado was also an EF2, around 130 mile per hour winds as well.
So this is interesting because I was talking about this on the air last night, and the orientation of the line, the way that the line was kind of situated and positioned is important because that provided the tornado potential for basically QLCS tornadoes. And this was by all means QLCS tornado. And it's loading up the data right now. We'll go to it and I'll show you what I'm talking about. So this is Mega Doppler. Archive radar data, so don't have to worry about anything, on the radar right now. Yeah, I wonder why that warnings was up there. It's supposed to be down there a little lower, but that's all right.
Look at all those warnings.
No,
That's
my goodness,
crazy.
there's so many warnings.
Yeah, and notice how every box or every yellow box is highlighted on the sides. That's considerable.
Yeah, and there's
thunderstorm
destructive.
warnings. Doesn't look like there was any sort of regular warnings issued last night for the severe level.
No, I don't think so. Which is crazy. Okay, load it up. So first of all, these are confirmed tornadoes. And here's what we're going to do. I'm going to show you as the system moved east. So here's the thing that was interesting. I was watching this in real time. Didn't do a Facebook Live, and the reason I didn't is because we had a dinner party at our house. So we literally had people over, and we were doing the play-by-play, and I was watching the radar. So first of all, if we look at this orientation of the line, set the storm motion from warning. Look at how the line with the velocity imagery is running from northwest to southeast. You can see that too with a spectrum that's a little noisy. But it's all about if it's a balanced cold pool and shear region. That's what you have to have balanced. And in order for it to be balanced and line up with the 0 to 3 kilometer line normal component, I know all this stuff's kind of flying over your heads, but there's the tornado that's showing up, and then you can see that's it developing and going towards Minko. And notice how it moves in a northerly direction. So with that being said, let's look farther south along the line. Here you're going to see that area of rotation that's popping up. And look at how the line is oriented from northwest to southeast again. Right here, it's kind of straight north to south, but then you got another area right here that's starting to spin up. So these are really hard to detect. There's a little bad radar scan right there. And then you see it disappear as it de-list. There's a tornado that's developing right here. And then there's the confirmation. If we look, you can see. Now, we actually determined that was looking like debris, wasn't it? Yeah. So let's go back to this. And we're going to go forward. And now look at this. This is what's crazy about this is that this storm, and this is what you have to know with QLCS tornadoes. The radar is telling you, hey, I'm going to form a tornado here. And I'm going to show you exactly what that is. So if we go back to Mega Doppler, I'm going to do this on our weather graphics system too. So let me load this up and do this on my weather graphics system. And keep in mind, it'll show the time on there, but it's not really the right time. So look at this right here. Here's what's happening. You are having what's called this descending reflectivity core. It's one of the signs of QLCS tornado potential. Now look, it's actually taking an arrow and it's pointing, I'm going to form a tornado, and it's going to be most likely right in this region. You also have what's called coupled notches. You also got a little bit of a surge in the reflectivity. Now, if we step forward in time, watch what happens. We're seeing that descending reflectivity core. Again, exactly where I've got it pointed out. I was zoomed in, and it's like exactly right there. And now look. So again, I'll move this over just a smidge to line it up with that. So before you even look at the velocity, we can see this descending rear inflow jet, which is one of the signs that tornado potential is starting to develop. So Danielle, just to let you know, this is archive radar data from yesterday, Oklahoma City, Norman. It was all the tornadoes that were happening last night. This, by the way, is not 10 o'clock, 11 o'clock. It was actually a lot earlier than this yesterday evening. So here's what I'm going to do. I'm going to take the banner off the screen just so you don't have to see that. So this is all archive radar data. But here's what we're going to look at, the velocity image. And look, you can see the developing tornado right here. Now, one of the reasons you can is because of and I know that hindsight's 2020, but I can tell you for a fact that I was actually calling this tornado before it even develops. And I've got eyewitnesses to prove it. So there's the circulation that's starting. You can see this blue shaded area. Those are really, really, really fast winds racing towards the center of the storm. So basically, I'm going to remove all this stuff. Go ahead. I want to change that color. I don't want that. I want that white. So these are winds that are going towards the radar, away from the radar. And so there's your circulation right there in a counterclockwise rotation. Now watch how this develops over time. There you go. There's your couplet right there. And at this point, there's nothing that's showing up on the radar, and there's no debris signature yet. But it's just about to touch down. Now, according to the survey, they actually said it touched down a little bit southwest of this. Mm-hmm. So it did actually touch down very close to I-35. But, Danielle, again, this is in Norman, Oklahoma from last night. Here we are at 9:20, or excuse me, 10:20. This is, no, it's 9:20 because daylight saving time is not. So this is 9:20 in the evening. There's the area of rotation. And then look, now there's your tornado. Look at how that evolved. Let's go back a little bit in time. You can see how it's starting to develop. But remember that descending reflectivity core right there, it's pointing to it. Now it disappears after that, but that image right there can tell you everything that you need to know about that. Look at that descending reflect. And then you can also see what appears to be a hook. So there's a circulation. This plus right here, by the way, just to let you know, that's the National Weather Center right there. That's where the National Weather Center is located. So this touched down just east of the National Weather Center. In fact, I used to have an apartment right here, and this used to be a driving range right over here. This is exactly where the tornado came through. I know this area so well because, I lived there. And we go back, put the radar on. There's the area of rotation, and then now watch debris. And the PTDS is going to pick it up in one scan right here. Boom. There it is. That fast.
It just shows you how dangerous QLCS tornadoes
QLCS tornadoes are so dangerous. Yeah, I would agree with that, John. And QLCS tornadoes pop up real rapidly and then they disappear. So there was damage at Clawson and Highway 9. Yeah, Clawson and Highway 9. Wow, just wow. So look at how fast that developed. So here's the bad thing about the PTDS. Number one, these storms are moving really fast. But the tornado detector can only detect it if there's debris that's being tossed in the air. So if we're looking at this and we're saying there's no tornado, well, we look at the velocity, you can tell it is. That's where it most likely touched. This is where it smashed a bunch of stuff. Well, keep in mind there was no other debris that might have got tossed. There was some trees and tree limbs, but this is when it actually hit stuff and threw it up in the air. Now the radar beam's extremely low, by the way, 636 feet above the ground. There's the circulation. We look at the velocity. Spectrum width isn't very helpful because it's so low to the ground. You're starting to get a noisy signal, but that is just a classic textbook couplet, very close to the radar. And I even said last night, I was like, I bet you this is going to be high-end EF2, perhaps maybe EF3. And it may still get upgraded. Yeah. So I know it's at least EF2. There's the circuit. Now look at all the debris that's starting to get tossed about. So if we look, here's all these homes that were hit right in this area, just to the west of Lake Thunderbird. There's the radar that's located. And then this is another thing. Look at that descending reflectivity core. So the radar is going, okay, I'm about to produce, and it's going to be right here. So let's see where that lines up with the velocity image. Pretty darn good. Very, very close. So that's that rear inflow jet that's surging. That's actually almost like spinning a basketball on the corner of your finger. That's allowed that storm to spin up even more. Now, here's another thing, too. After this line starts surging out, that tornado lifts north. Now, where do you think the next tornado is going to be? Let me remove this off the screen here. Look at this. Look at what we've got. We've got another descending reflectivity core, don't we? Those are not radar artifacts. For a while, I thought those would be radar artifacts, but they're not. So if we look at the velocity image, now we're starting to see, first of all, this is the tornado still, very close to the radar, very intense circulation. Now we're starting to see this line. Now, the bottom part of the line, I don't have to worry about tornado potential. Even though when I look at the normalized rotation, it's got all these circulations all the way up and down that, but I know that that doesn't line up with the shear. The line has to be oriented from northwest to southeast. So as we put this into motion, watch what happens. Now look, the northern edge of the line right here is starting to ramp up. First sign that it's about to produce is going by there. This is still the tornado that's on the ground. So the tornado touched down and almost hit the Shawnee Mall. And here's I-40. And I know that it was right now. Look, right here on the leading edge of the line there, you can see that descending reflectivity core. The velocity images show you a lot more than the normalized rotation. It's not very good when you're that close to the radar. These are bad radar trips. How do I know that? Well, if I look at the velocity, you can see this is de-alias, so it's not, or it has some bad data. This is actually, it already is de-aliased. So this is de-aliased, and it still is bad. So that's what causes that to freak out. Then you'll see the normalized, they disappear. If they show up and they don't move and they disappear, then you know they're bad, just like that. So those are bad, so you don't look at those. But when we go back to the velocity image, now look, we're getting that line. It's oriented in a northwest to southeast fashion. I know that those two areas are very conducive to tornado potential. And I was like, I bet you the next tornado is just northwest of Shawnee. And at this point, it was starting to develop. And there it is.
That was just northwest of OBU.
Just northwest. And here's the Stroud Mall. And I think it just barely missed the Stroud Mall to the west. But I was watching News 9's coverage, and they actually had the tornado lit up by lightning, by power flashes. And the power flash lit that up. So north side of Shawnee gets hit too. So that the north side of Shawnee gets hit because here's the tornado that's developing. So let's go back to the velocity image. Let's kind of pan back and forth on this with the keys. So you can see the way that that's surging, and look at how that develops. Now, is there any descending reflectivity core? You bet. Absolutely. And not only that, but a line break too. Look at how this line breaks apart. That's another confidence builder of QLCS tornado potential, is that line break. So if we go back, we're looking at this. There's your circulation. Now watch the debris that pops up right as it crosses I-40. Nothing. Bam. There it is. There's the tornado. What's interesting is you look at the TBS and it's showing it to the west. That's not a true TBS. How do I know that? I look at the reflectivity and it's not co-located with the strongest reflectivity. So it's a false reading. It absolutely is. And I don't know all the mechanics of radar that causes the false readings. I just know they are, if they're not co-located. So this is a true circulation. This is not. But if I look at that real quick, it's like, whoa, that normalizes way up there, but it's not. So we go back to the PTDS and watch what happens. You know that that is on the ground and producing damage. And look at how that's spreading out as well. But this is what I love about this product, is that if we're looking at this, that doesn't look like tornado potential there. If you're looking at this, maybe. If you're looking at this is pretty clear cut. But there's a lot of other noise. And then you look at this and you go, okay, I don't know exactly where it is. Yeah, makes it much easier. So that's why we do that with PTDS. So, anyways, there's a storm moving north. Now, what's also interesting too is you see it's like a ball. It's almost like a very solid circle. That's a sign that the tornado is still on the ground. And the reason I know that is because if you're spinning something, it's going to stay in towards the center of it. Once it stops spinning, it's going to get released and start to spin out. Because all that debris is kind of held within the circulation. Mm-hmm. But we go back to that CC. Watch this start to spread out right about here. See how it's not a solid ball anymore? It's kind of fanning out. If we look at the velocity image, it started to weaken. It's my belief that that tornado lifted at that point. But there's still debris in the air, but it lifted. And I think it would be just north of 62. Mm-hmm. And I wonder, do they have the tracks already?
I didn't see the track, but they released the ratings.
The survey.
So
yeah.
That one was an EF2, and then that one that we showed on the west side of Oklahoma City was a confirmed EF1 too.
Yeah. And then that's as far as the radar data goes. So in review, and here's another tornado warning. Look, and it's on that northwest southeast oriented line. Now, here's the thing. It's not always northwest southeast oriented on the line. It's got to line up with the shear and for that specific environment. So sometimes it needs to be oriented northeast to southwest, just like what you're seeing here along the part of the line. But not in this instance yesterday. That was the favorable motion.
And I just looked. I think they confirmed an overall, I think it was a total of 5 confirmed tornadoes that they've surveyed so far.
So far. Now I don't know if I can get the archive for those products. I don't think you can. Which is a bummer. I wish you could. Is there any way to get the 0 to 3 kilometer?
I'm not quite sure personally.
I don't think you can. Let's see here. Mobile version. Maybe I can get it this way. Let's look here. Multi-parameter fields. Lowest kilometers. But I don't think you can loop this, can you?
Mm-mm.
Yeah, you can't.
There should be a way to do that.
Yeah, because that's important for QLCS. 0 to 3 kilometer cape, vorticity. We could do the 0 to 3 kilometer cape, but I just don't think you can get those. Yeah, parameter selection. You can get a lot of other stuff. You just don't get that. Yep, that's not in there. Multi-parameter fields. And then you look at multi-parameter fields. And it stops at hail parameters. Multi-parameter fields, hail parameters. Maybe it's an oversight. I better tell them to add that because that's a good thing to look at. All right, guys. 12 tornadoes so far, someone said. Matthew Ellis said.
Okay. I'm looking at the Norman, so I'll check back with that branch out.
So, anyways, I think that's enough analysis for the night. But we're going to be dealing with this analysis again, as we're going to have QLCS tornado potential. We're also going to see the system on Thursday. That means business, man. Big time business.
It's just that time of year, unfortunately.
Yeah. Done a lot of research on QLCS tornadoes because they're such a pain. And, James Spann said it best. Hindsight's 20/20. You can look back and you can see a lot because you already know what happened, so it's a lot easier. But I will say in real time, that training helped out because I was like, there's a tornado in Norman right now, and they haven't warned. And we were watching, some coverage, and there was, granted they had 4 or 5 other tornado warnings, and so it's probably easier when I'm sitting at home being armchair quarterback. But I did see that before it was happening. Oh yeah, Robert, we're going to be doing Facebook Lives multiple times this week, and we're going to be doing coverage. I almost guarantee you it's going to be a really busy one Thursday. Thursday's system looks like trouble.
Gonna be running and gunning.
It's going to be rough. Now, I don't know if it's going to be rough exactly here, but somewhere in the area or vicinity is going to have a major severe weather potential. It's just too strong of a system. So where all is the Thursday system predicted to hit? Should we show them that? I'll show you the future radar. I got to go out just a little bit more. Basically everywhere. It's going to hit multiple states. It's going to be, and it's already bad news on the West Coast. So we know that that's a problem.
For the severe weather Thursday, it could be a doozy for portions of Texas, Oklahoma, Arkansas, and Louisiana, just to name a few.
All right, so take all that off. Take that off. So here you go. Ready? Select all keyframe. Whoa, I don't want to select that one. Just delete that. Kind of wish some of this stuff was easier to set up. Okay, so stand by. Here we go. Future track. Everything's pretty quiet. Here's Wednesday's storms that pop up. Yeah, a little bit of rain in the river valley. That's why we bumped it up a little bit. I think I'll bump it up even more. I got to enter in my numbers fast for. I expect the upgrade for the enhanced. And then here is Thursday. Clouds are catching up. Look at this. Oh, man. That's as far out as the model goes. It stops right there. There's your thing. Oh, yeah, by the way, we're under a slight risk of flash flooding potential 4 days out. So the 4-day outlook. All right, guys, I got to run because I got to put in some forecast numbers, and we will catch you guys later. See ya. Hey, Josh, thanks for all your help today, man. Appreciate it. It was awesome. I'm going to go get some sleep. Nothing severe now, no, but this could be trouble. See you guys.